The term JCL stands for Job Control Language. It is one of the oldest scripting language predominantly used on IBM Mainframe. JCL is a language that tells IBM ZOS which resources are needed to process a batch job. As a technical professional in the world of mainframe computing, you should know what is a JCL and how to write a JCL to accomplish your daily task. Ladies and gentlemen, welcome back to our channel. And the topic for today's session is JCL. The intent of this session is to teach you JCL. If you are fresher, then this JCL tutorial will start you from the beginning. And in case if you have experience, then this session will elevate your skills to a next level. So ladies and gentlemen, before I start with today's presentation, I would request you all to do subscribe to our channel because we need your support to grow our channel. And in case if you have already subscribed to our channel, then I would like to say a big thank you for your subscription. And we are also hosting a monthly contest in which 5 lucky winners will going to get access to the advanced version of this course on Udemy or Skillshare. To participate, you need to subscribe to our channel and leave your feedback about the video in the comment section. So without wasting any time, let's focus on today's agenda. So we start today's session with an introduction to IBM Mainframe. Then we will try to understand the term JCL and why it is important from a mainframe perspective. Then we will deep dive into different stages of JCL, followed by job control statements. In that we will discuss job card, execute statement and DD statements. And after that we will look at different coding rules which is applicable when you write a JCL. After that we will look at JCL parameters that include both positional and keyword parameters. In fact, we will look at a couple of important parameters that is used when you are writing your JCL. After that, we will also look at JCL procedure. In this section, we will focus on Instream procedure and catalog procedure. And in fact, how to override the parameters using the set statement. In the later part of this JCL tutorial video, we will focus on JCL utilities, for example, JCL SORT, IEBGENER, IEFPR 14, and after that we will focus on generation data group and why and where you use GDGs. And the last section is dedicated to JCL tips and tricks, where we will be focusing on how to process job conditionally, that is with the help of JCL COND parameter or if then else statement. We will also look at what is the difference between JCLLIB, StepLib and JCL order. So ladies and gentlemen, sit back and grab a cup of coffee and do watch this video till the end because I've spent a lot of time preparing this presentation. So let's get started with Introduction to Mainframe. Mainframe computers play a central role in the daily functioning of most of the world's largest corporations. However, the other form of technologies are used extensively in various business capacities. But mainframe occupy the central position in today's e-business environment. In banking, finance, healthcare, insurance, public utilities, government, and other public and private enterprise, the mainframe computers continue to form the foundation of modern business. Now the question is, when did mainframe computers came into existence? The origin of mainframe computers dates back to 1950s. In those days, mainframe computers were not just the largest computers, in fact, they are the only computers, and it was very few businesses that could afford them. In 1960, the course of computing history changed dramatically when mainframe manufacturers began to standardize the hardware and software that they offer to customers. The first wave of customer business applications were mostly written in assembler, COBOL, Fortran, or PL1, and the substantial number of these older programming languages are still in use. In the decades since 1960s, Mainframe computers have steadily evolved to achieve enormous processing capability. In today's era of cloud computing, mainframe is still considered as the most powerful, secure, and reliable computing platform. Now, let's focus on the term JCL. So, the term JCL stands for Job Control Language, and it is primarily used on the IBM mainframe to convey information to ZOS operating system through a set of statements called as Job Control Statements. JCL is a scripting language. In fact, it is one of the oldest and robust scripting language. Precisely, the purpose of JCL is to provide information related to the program, dataset, and the input-output devices to be used during the execution of a job. Now, before discussing the different categories of job control statements, let's try to understand the different stages of JCL. This will help you in visualizing what happens behind the scene when you submit a job on the mainframe. During the life of a job, JAS2 and the base control program of ZOS control the different phases of the overall processing. The job queues keep a track of the job that are waiting to run or currently running on the system or waiting for their output to be produced or probably waiting to be purged from the system. Generally speaking, a job goes through 6 different stages. First one is input, second one is conversion, third one is processing, and the fourth one is output. Fifth one is print, and the last one is purge. Now, let's try to understand the significance of each stage with the help of an example. So here's a programmer who wants to calculate the monthly tax for a specific department. So as a first step, he's going to write a JCL with all the relevant information such as the program name, the input-output dataset names, and other accounting information that you need to specify in a job card. In second step, the programmer carefully review the job and submit the job for execution. In third step, JAS to accept the job, it uses a converter program to analyze a job's JCL statements. If JAS2 detect any JCL error, it issues message and the job is queued for output processing. If there is no JCL error, then JAS2 queues the job for execution. In the processing stage, ZOS execute the job. In the background, the initiators examine the JAS pool, select an appropriate job for execution, execute the job in its address space, and return the resources for another job. In the output phase, once the job is completed, JAS2 collects the output and sends it to print based on an output class and the device setup. In the last phase, the user can view the output in a spool. The output can be a report, a new dataset, or a database update, but that depends on the business requirement. In this example, the monthly text report will be available in spool because we do not want to print on actual printer. Now, there are two important terms that you should be familiar with. First one is JAS. So the term JAS stands for Job Entry Subsystem. It actually keeps a track of jobs that enter the system, present them to ZOS for processing, and send their spooled output to the correct destination based on the parameters that you provide in your job card. And the second important term is initiators. So an initiator is a system program that processes JCL. Set up the necessary environment in an address space and runs a batch job in the same address space. You can also have multiple initiators, that is, each in an address space. Multiple initiators permit the parallel execution of batch jobs. Now let's talk about the job control statements. So as you know that JCL is used to convey the information to ZOS through a set of statements, and these statements are called as job control statements. And there are three kinds of job control statements. First one is job statement. A job statement actually marks the beginning of a job, and it is used to provide the vital information related to your shop. The second statement is execute statement, and it is generally mark the beginning of a job step, and it is used to provide the program name or the proc that you want to execute. And the third statement is data definition statement, or DD statement. And these statements are generally used to provide information related to the input and output datasets. In every job, the control statements are grouped into job steps. A job step consists of all control statements that needs to run one program. So if you want to run more than one program in a single job, then you have to write separate step for each program. And the step will going to have execute statement that will specify the program name and a couple of DD statements that will specify the dataset that you will be using in the program. Now the question is, do you really need to include all the three types of control statement in a JCL? Well, the answer is no. You should always remember that every job must contain a minimum of the following two types of control statements. First one is job card to specify the job specific information, and second one is execute statement to provide the name of the program or the utility that you want to invoke with the help of a JCL. DD statements are optional and they are only required in case if your program or utility is using any dataset. Now let's try to understand what all we discussed so far with the help of an example. And this example will help you in connecting the dots, how exactly the different job control statements are included in a job step and how these job steps are combined to form a job. So if you look at the right hand side of your screen, you have an example, and this example illustrates how exactly the job control statements are linked to the COBOL program name or the file names, right? So if you look at this example, on the top section you have a sample JCL that will execute the program TREMP001. And at the bottom section is actually a small snippet which is being picked up from the COBOL program, right? So the first two lines of the JCL is actually a job card. So job card is used to specify the information related to the shop. And next three lines I've used as a comment, and the comment I've specified just to inform what exactly this JCL is doing. So I've mentioned that JCL to run TREMP001 COBOL program. After that you have an execute statement which is actually a beginning of step of that particular job. So I've specified step name as step 01 execute pgm equals to tremp001. So this is actually a name of a COBOL program, and if you see I've already highlighted this with an orange color. After that you have a DD statement that is steplib. Steplib is actually used to specify the library where the load module is residing, right? So we're going to discuss that in the later part of the section in detail. So as of now, just remember that the system will going to pick the load module from this particular library. After that you have a DD statement that is EMP mast, that is employee master file, and EMP REPT, that is employee report. So these are the two files. One is an input, other one is an output file, and these two input files are used as it is in the COBOL program. So if you see the file control section of the COBOL program, which is mentioned in the bottom section, you'll have the first file that is EMP in. So this is actually a file name which is mapped to EMP mast of the JCL, right? And after that you have sysprint and sysout. These are the two DD statements which is used to specify where you want to print your job related messages. Now, before discussing the job control statements in detail, let's discuss two important topics. First one is the coding rules of writing JCL, and the second one is JCL parameters, that includes keyword parameter and positional parameter. And these are very important because they are the one which is actually used to define your control statements. So let's get started with general rules of writing a JCL. So the JCL statements are coded as 80 byte records. Out of those 80 bytes, first 72 bytes are used for JCL statements, and last 8 bytes are reserved for optional sequence number. And remember, no statement should go beyond column 71. And just in case, if there is a statement which is going beyond column 71, then you can use next line after putting continuation in column 72, right? Now each JCL statement can be logically divided into 5 fields. First one is identifier, second one is name, third one is operation, fourth one is parameter, and the fifth one is comments. And remember, it is not necessary to have all these 5 fields on each and every JCL statement, right? So now let's look into all these fields one by one. So the first one is identifier field. The identifier field start in column 1 and it is used for all standard JCL statements. Every JCL statement should start with an identifier field, that is 2/, and after that you can have a name or an operation field. Now the important point is that there are 4 different exceptions to the identifier field. First one is if you're using 2/ followed by a name or an operation, so it would be treated as a normal JCL statement. In case if you're using a single / followed by asterisk, then it would be treated as end of the statement, and it is generally used whenever you're using sysyn to pass certain data to your JCL. Apart from that, you have 2/ followed by asterisk, then it would be treated as comment. That means that is generally used whenever you want to include any comment what exactly this JCL is doing. And the last one is 2/ followed by all spaces. So that is treated as null or end of the job. The next field is name field and it begins in column 3. The name field is generally used to provide the name to a JCL step. In case if you're writing a job statement, then you have to specify the name. In case if you're writing EXEC or DD statement, then it is optional. The minimum length of name field is 1 and the maximum length is 8 characters. The next field is operation field, and this field is used to specify a valid operation code such as job, EXE and DD for job card, execute statement and DD statement. The next field is parameter field and it is used to specify the parameters based on the operation field. And there are generally 2 kinds of parameters which is specified, and that is positional parameters and keyword parameters. And we will look into all these parameters in detail in our next slide. So as of now, just remember that this section or this particular portion is confined for different parameters that is defined based on the operation. If it's a job operation, then it would have parameters related to a job card. If it's an execute statement, then these parameters will be related to an execute statement. And in case if you are using a DD statement, then these parameters will be associated with DD statements. And the last field is sequence number. So sequence number is actually optional. It's not used anymore now. These are used in 1960s for punch cards. Now let's talk about second subtopic, that is JCL parameters. So the JCL parameters are broadly categorized into 2 categories. First one is positional parameter and second one is keyword parameters. A positional parameter must be placed in a specific position within the JCL statement. If you want to omit a positional parameter, then you must replace that parameter with a comma. So in the following example, I have used 2 positional parameter. First one is accounting information, that is 5 times number 9, followed by username, and in username I have specified Topictrick, and both parameters are highlighted with green color. I hope by looking at the example you are able to understand what are positional parameters, and in nutshell that positional parameters have a specific place in a control statement, right? Now let's talk about keyword parameters. The keyword parameters have no special position or order. However, they follow any required positional parameters within a job statement. For example, in this case, the keyword parameter message class and message level is coded after the positional parameter, that is accounting information and username. And always remember that a keyword parameter is always followed by an equal sign and a value. So in this example, message class and message level are the 2 keyword parameters which is used in job statement. Now, let's get back to our original discussion of job control statements, and let's discuss each job control statement one by one. So the first one is job control statement or job card. A job statement is the first statement of any JCL. It marks the beginning of a job and assign a name to it. The job statement is used to provide certain administrative information, including security, accounting, and identification information. And you should always remember that a JCL can have one and only one job card or a job statement. You cannot have more than one job card in a single JCL. Now, let's deep dive into the syntax of job card. In this section, we will look at different parameters, for example, keyword parameter or positional parameter that is used to define a job card. So the syntax of job control statement is fairly simple and easy to understand. The only thing is you need to remember that you have to use positional parameter at a specific position, right? And then you can use the keyword parameter as per your requirement. So as we discussed in our previous slide, that standard JCL statement begins with an identifier. So in this case, first 2 bytes would be an identifier, that would be 2/. After that you have job name. A job name is required on every job statement, and the maximum length of job name is 8 characters. After that you have a space followed by an operation field, and in this case it would be job because you are writing a job card. If it would be an execute statement, then the operation field would be execute, and in case if it would be a DD statement, then the operation field would be DD. Then again you have a space followed by positional parameters. So in this case we are using two positional parameters. First one is accounting information and the second one is programmer name. Accounting information actually denotes a group or a department that actually owns the billing of a job based on CPU usage. And the second parameter is programmer name, and it is used to denote the name of a person who is actually responsible for the job. However, in most of the cases, we use either the department name or the project name or probably a group name instead of an individual programmer name. The next set of parameters are keyword parameters, and as you know that there is no specific sequence and you can code them in any sequence of your choice. The first parameter is class parameter, and you can use the class parameter to assign the job to a class. And again, the class you should request depend on the characteristics of the job. And of course, it also depends on the rules which is used to assign a class. The next parameter is message class, and it is used to assign the job log to an output class. The job log is a record of job related information. And remember, the value of message class should be a valid, and it can be between A to Z or 0 to 9. And before providing this value, it is always recommended that you just go back and check the possible value with your system administrator. The next parameter is message level, and it is used to control the listing of JCL output for a job. It is actually a single digit that specify which JCL statement should be printed. And in message level, you passed two subparameters. First one is for statement, other one is for message. And the possible value of statement is 0, 1 and 2, and for message is 0 and 1. So as a practice, we just pass 1 for both statement and message. So in most of the JCL, you'll see message level equals to 1, 1. So that means you're going to print all the messages related to a job statement or system related messages. The next parameter is notify, and it is used to notify the user automatically when the job is completed. So far we have discussed couple of important parameters which is used to define a job card. So these are not the only parameters. We do have couple of more parameters that are used in a very specific situation. For example, time parameter, which is used to provide the time, and in case if your job fails due to time exception, then probably you can allocate the maximum time to a job. Similarly, you have region parameter, then you have restart parameter, which is generally used to restart your job. Then you have type run parameter, which is generally used for special job processing. So we're going to discuss about all these parameters in JCL tips and tricks section. Now let's focus on the execute control statement or exec statement. So as you know, the exec statement marks the beginning of a step within a job. And I hope you remember that job control statement actually marks the beginning of a job, and exec statement marks the beginning of a step within that particular job, right? And the exec statements are generally used to specify the name of a program or a catalog procedure or an Instream procedure that you want to execute. And one of the important points that I want to highlight out here is that a job can have a maximum of 255 steps. This maximum include all steps in any of the procedure that execute statement has called. Now let's talk about execute statement syntax, and let's see what are the different parameters which is being used when you're writing an execute statement. So as you know that execute statement is used to specify the program or the proc name that you want to execute with the help of the JCL. Now the syntax of execute statement is somewhat similar in both cases, whether you are executing a program or a proc. However, there are few additional parameters that needs to be provided in case if you want to override or if you want to pass any value to your program with the help of a JCL. So let's look at each syntax one by one. So first one is execute statement for executing a program. So an execute statement begins with an identifier. After that you have step name. So step name is optional, but it is always recommended that you use a proper step name. After that you have an operation keyword. So in this case it would be exec because we are writing an execute statement. After that you have PGM equals to program name. So this parameter is used to specify the name of the program that you want to execute. Although the PGM parameter looks like a keyword parameter, but it is a positional parameter and it must be coded first on the exec statement. The next parameter is PALM, and it is generally used to pass information to your program with the help of a JCL. Now let's look at the different variant of execute statement, and this variant is generally used to execute proc, and it could be your Instream proc or catalog proc. That depends on the nature of requirement or the way you are designing your JCL. So in this case the syntax is almost same. You have an identifier, then you have step name, then you have exec statement, and after that you have a positional parameter once again, and that is proc equals to, where you have to specify the proc name that you want to execute. And in case if you want to override the value of any parameter which is defined in your proc, then you can use the parameter dot the proc step name followed by a value. So in this way you can add, modify or nullify the parameters which is defined in your procedures or proc. And remember, proc equals to proc name is a positional parameter. It's not a keyword parameter, right? Now let's focus on DD statements or data definition statements. So DD statements are generally used to define data sets that you generally use in your programs. The data definition statement or DD statements are used to define the characteristics of a dataset. When I say characteristics, that means the record length, storage requirement, and its organization. The syntax of DD statement is a bit complex because the parameters can be coded in various combinations depending on whether the dataset is new or old, temporary or permanent, or maybe catalog or uncatalog. Now let's focus on the different parameters that you generally include when you're writing a DD statement. The syntax of DD statement begins with an identifier. Then you have DD name, which is actually a symbolic name of a dataset that you are accessing in your program. After that, you have DD as an operation field, and then you have DSN name. So DSN name is used to specify the file dataset name. The next parameter is disposition parameter, and it is used to describe the status of a dataset, and the processing of a dataset at normal and abnormal termination of the job. The disposition parameter may have up to 3 positional subparameters, and if one or more subparameter is used, then it has to be separated by comma, the way I have just mentioned in the slide. So we're going to discuss all these parameters in detail in our next slide. The next parameter is unit, and it is used to specify group name, device type, or device number that identify the device where the file is residing. And remember, if the file is already cataloged, then you are not required to code unit parameter. The next parameter is volume equals to serial, and it is used to specify 6-character volume serial number of the volume that contains the file. Again, it is not required in case if your dataset is already cataloged. The next parameter is space, and it is used to specify the -d space to be allocated for the file. And finally, the last parameter is DCB, and it is used to specify the characteristics of the file. When I say characteristics, it means the record format, logical record length, and the block size. Now, let's deep dive into the DD statement parameters and subparameters that we have discussed so far, so that you can have a complete picture and what are the different permutation and combinations through which you can write a DD statement. So the first one is DSN name, and as you know that DSN name is used to specify the actual dataset name. So the limitation out here is the maximum length of a qualified dataset name is 44 characters, and that include period, right? In case if you have a GDG, then the limit is 35 characters including period, and in case if you have a tape dataset, then the limit is 17 characters including period. For example, tp.emp.sal.text.file is the actual name of a dataset which is created on mainframe, and it is actually an employee salary file for that particular month. The next parameter is disposition, and it is used to specify 3 positional subparameters. So the first one is file status, and this subparameter identifies the status of a dataset before the job is executed. The possible value of first positional subparameter is new, old, share, and mod. And by default, if you do not specify anything, then new is assumed. The value of second positional subparameter is to instruct the operating system what to do with the dataset if the job ends normally. And the possible values are delete, keep, pass, catalog, and uncatalog. And the default value is delete. So if you do not specify anything, then by default delete will be assumed as a normal disposition. So eventually, if you specify file status as new, then normal disposition would be delete, and if you specify file status as old, share, or mod, then normal disposition would be keep. Finally, the value of abnormal disposition parameter instruct the operating system what to do with the dataset if job ends abnormally. And the possible values are delete, keep, catalog, and uncatalog. Now the next parameter is unit, and as you know that this is used to specify the tape or disk devices where actually your dataset reside. So in case if your dataset is already cataloged, then you're not required to specify the unit parameter, and in case you want to allocate a file, then you have to specify the unit parameter, right? And in general we use sysda or tape, and in case if you have any specific device number, then you can use a device number also. The next parameter is volume equals to serial number, and it is used to specify the volume number on which you want to allocate your dataset. For example, unit equals to sysda, comma, volume equals to serial equals to MMS9TV. So this is actually a serial number where I want to allocate my datasets. Now we are left with two important parameters. First one is space parameter. So the space parameter is used to allocate space for a new dataset. And again, it's a combination of multiple subparameters. So let's try to understand what's the significance of each subparameter. So the first subparameter is unit, and it is actually used to establish the unit of measure for a space allocation. And in most of the cases, it is cylinder or track. And if you are using cylinder, then you would be using short form CYL. And if you're using track, then the short form would be TRK. The next parameter is primary quantity, and it is used to specify the number of units to be initially allocated to the file. Second one is secondary quantity, and it is used to specify the number of units to be allocated to each secondary extent. The next subparameter is dir, and it is used to specify the number of directory blocks to be allocated for a partition dataset. The next subparameter is RLSE, or it is also called as partial release. It is generally used to release the unused space when the dataset is closed. And the last point that I want to highlight before we move to the DCB parameter is that space parameter is only applicable for non-VSAM datasets. Now let's talk about our last parameter, that is DCB. So the term DCB stands for Data Control Block, and it is used to specify the characteristics or attribute of a dataset. So it has different subparameters, and each subparameter has its own significance. And these subparameters are keyword parameters, so they can be coded in any sequence. The first subparameter is DSOrg, and it is used to specify the dataset organization. And the following values are the possible values. First one is PS, that is physical sequential, PO, that is for partition, DA, that is for direct, and IS for index sequential. The second subparameter is record format, that is recfm, and it is used to specify the format of file records. And the possible values are F, FB, V, VB, VBS, and U. F stands for fixed length, FB stands for fixed block, V stands for variable length, VB stands for variable length block, VBS stands for variable length block span, and U stands for undefined. And the next parameter is logical record length. It is used to specify the length of the file records. And the last one is block size, and this parameter is used to specify the length of the file block. For fixed block, block size is normally a multiple of logical record length. So if you look at the following example, where I've used the DCB parameter and I've used a couple of subparameters to define the dataset. So logical record length is 80 and block size is 800, and the record format is fixed block. And another important point that I want to highlight is that again, DCB parameter is used to define the characteristics of a new dataset. And in case if dataset is already present, then you are not required to define the DCB over there. So ladies and gentlemen, so far we have discussed a lot of different topics, starting from what is mainframe, then we have discussed what is JCL. After that, we have looked at different kind of job control statement, that is job statement, execute statement, DD statement, what are the different parameters, that is positional and keyword parameters. Now let's devote some time to JCL procedures, or proc in JCL. So in layman term, a JCL procedure or proc is a pre-written segment of code that include one or more job steps. And due to this fact only, a JCL proc can be executed or invoked from a JCL. It cannot be executed on its own. By using procedures, the amount of JCL code you have to do is reduced, resulting in fewer coding errors and thus improve the productivity of the programmer. Now let's talk about the different categories of JCL procedures. So in general, JCL proc is divided into two categories. First one is Instream procedures and the second one is catalog procedures. Now let's talk about JCL Instream procedures. So Instream procs are the one which is actually included in the job itself. An Instream procedure begins with a proc statement and ends with a pend statement. However, pend statement is optional, But as a practice, it is always recommended that you should use pend statement at the end of your Instream procedure. And all the job control statement that you mention between proc and pend is treated as a part of Instream procedure. JCL statements falling between the proc and the pend statement are not executed when first encountered. Instead, they are scanned for errors and retained as a temporary procedure. Any JCL statement that falls after the pend statement are recognized as normal statement and are executed. Last but not the least, an in-stream procedure should be placed near the beginning of a job stream before an execute statement that refers to it. Now, before looking into the example, here's a question for you. And the deal is that you have to write the correct answer in the comment section. So the question is, what is the maximum number of in-stream procedure you can write in a single job? And I'll let you know the correct answer after discussing the following example. So here's a sample JCL that includes an in-stream proc, and I would be invoking this in-stream proc within the JCL itself. So let me quickly walk you through with the sample JCL. So first two line is a job card, and we have discussed in our previous slides how to write a job card. The next three line is a comment, and it is always recommended that you should include precise description of what this JCL is actually doing. So in this case, I've included a short description that says JCL to calculate employee annual tax. After that, you have in-stream proc, and the proc begins with a name and a proc keyword. And always remember that you should have a proper name for a proc, otherwise you will not able to invoke that in your JCL. After that, you have couple of job control statement, that is an EXEC statement to execute a program, that is EMPATAX. Then you have 3 DD statement, 2 is for dataset and 1 is for sysout, just to print the messages on the spool. And then you have a pend statement, which is actually mark the end of the in-stream proc. However, it is optional, but it is always recommended that you should use pend statement so that you can clearly make out that this is the in-stream proc. And finally, you have step 01, which is actually an execute statement, and it is invoking the in-stream proc that we have defined in the JCL. So again, it's pretty simple. You need to just write the step name followed by an execute statement, and then you can just specify the proc name, or you can use proc equals to proc name. It's your choice. Now it's time for the answer. So the maximum number of in-stream proc that can be included in a JCL is 15. So let's see how many of you have got the correct answer. Now let's talk about the catalog procedures. A catalog procedure is a series of JCL statements that are stored in a partition dataset or a proc library. Catalog procedures can be invoked by any JCL on the system. However, if you're using an in-stream procedure, then that procedure can be invoked from a JCL in which it is defined. So that's a basic difference between in-stream proc and a catalog procedure. Now the catalog procedures can be stored in system procedure library, that is sys1.proclib. However, this library is used to store IBM supplied catalog procedures. You can also have catalog procedures in a private library. The name of the catalog procedure is its member name or alias in the library. So before discussing the catalog procedure example, let me ask an interview question. And if you know the correct answer, then write down in the comment section. So the question is that let's say you have created a catalog procedure and you have stored that procedure in your private library. Then how will you invoke this catalog procedure with the help of a JCL? Now let's focus on the example. The following example has two sections. The top section is a catalog procedure and the bottom section is a sample JCL that invokes this catalog procedure, which is stored as a part of a PDS member. So the catalog procedure again start with a proc and end with a pend statement. And all the statement that is included between proc and pend statement is treated as proc statement, and they can only be executed when the proc is invoked with the help of a JCL. Now let me explain the second section of this example. So here's a sample JCL that will execute or invoke the catalog procedure that we have discussed in the above section. So the JCL has two important steps. First one is job card, which is used to specify the information related to your shop. After that, you have comment section, which is used to specify what the job is actually doing. And after that, you have an execute statement, which is actually executing or invoking the proc, which is stored in the system library, that is sys1.proclib. So far we have discussed what is a catalog procedure and how you can invoke a catalog procedure if it is stored in system library, that is sys1.proclib. Now let's try to find out the answer of our interview question, that in case if you store a catalog procedure in your private library, then what is the way of invoking? Are you do it in the same way, or do you need some additional steps? Right? So here's a sample JCL once again and a catalog procedure, but this time the catalog procedure is stored in my private library, that is tpt.prod.proclib. Now if you look at the JCL, so JCL also has the same number of steps, that is a job card, comment section, and then execute statement. The only additional step that I've included in this JCL is JCLLIB order. So JCLLIB is actually used to provide your personal PDS where you have stored the catalog procedure. So whenever you create a catalog procedure and you store it in your personal PDS, then you should always use JCLLIB before invoking that catalog procedure. Otherwise, the job will fail because system by default try to look for your catalog procedure in system libraries, that is sys1.proclib. And always remember that JCLLIB statement should be specified after the job statement and before the first execute statement, the way I have done in this particular JCL. Now let's look at the search sequence of this particular example. So in this example, because I've specified the JCLLIB, so system by default will going to search the catalog procedure in my personal PDS, that is tpt.prod.proclib. And in case if catalog procedure is not present in the private library, then system will try to retrieve the catalog procedure from system library, that is sys1.proclib. Otherwise, it will just retrieve it from the private library and continue the execution of the job. Now let's talk about two important topics. First one is how to override different parameters in proc, and second one is symbolic parameters. So before we discuss symbolic parameters, let's try to understand how to override different parameters in proc. So in general, you might have come across with a situation where you need to modify the file name or you need to pass any additional information to the program which is used in a proc or a procedure. So in such situation, you have two options. First one is you go back and change your proc or your JCL. And the second option is you can use proc overriding technique. So the proc overriding technique is the most preferred option, and it will enable you to add, modify, or nullify the values of subparameters which is used in a proc. And with this technique, you are not required to change anything in Instream or catalog procedures. Now let's try to understand the syntax of overriding the subparameters used on the proc execute statement and the DD statements. If you want to override the existing value of any specific subparameter which was defined on execute statement of a proc. So in that case, you have to specify the parameter name dot step name on which it is defined, followed by the value. And in case if you want to nullify the value of specific parameter which is defined on a specific step of a proc, then you have to follow the same process. The only thing is that you are not required to specify the value after the equal sign. And if you want to add a specific parameter to all the execute statement of a proc, then you have to specify the parameter name followed by its value. You are not required to specify the step name, because if you specify the step name, then that parameter will be added to that particular step of a proc. If you want to modify or add DD or output statement in a procedure, Then you can code the appropriate parameter on DD and output statement that follows the invoking execute statement. And if you want to nullify a parameter, then you can code the parameter without any value. That means you're not required to pass the value after the equal sign. The procedure step name is only required on the first override DD statement for a step. However, you can omit that on subsequent DD statements, but you need to remember that override must be coded in the same sequence as the DD statement in the procedure step. And in case if you want to override the output statement at a job level, then you are not required to specify the procedure step name. And before we look into the example, I would like to highlight that whenever you override any execute, DD or output statement, make sure you include all the subparameters that are not supposed to change or that will remain unchanged during this override process. So here's an example that illustrates how you can use the proc overriding technique to override the DD statement and execute statement. And this will clearly explain what all we discussed till now. So again, there is a sample JCL and we are using the same catalog procedure that we have used in our previous example. So in this case, first two line is again a job card, and after that you have next three line, which is actually a comment section that let you know what exactly this job is doing. So the next step is step 01, which is actually an execute statement, and this execute statement is invoking or executing the catalog procedure that is EMPTX010. And what I'm doing is I'm just adding a keyword parameter that is time parameter to the proc. And if you see the proc and the right hand side of your screen, you'll notice that there is no time parameter. So this is an additional parameter I'm adding to a step that is EMPTX010. And due to this reason only, I've specified the keyword time dot the step name of that particular proc, that is EMPTX010, and after that I've specified the value. And in next step, what I've done is I've just override the DD statement. So if you notice that EMPREPT is an employee report, if you look at the catalog procedure, it has a DSN name as tp01.employeefile.report. And in my JCL, I've just replaced the name with a different file. And how I've done that is that first of all, I've specified the proc step name, that is EMPTX010 dot DD name, that is employee report, followed by DD, then DSN and the dataset name. And after that, you have to specify the disposition of the file, whether it would be a share, new, old, catalog, as per your requirement. So with the help of override proc technique, you can modify or change any of the keyword parameters which is defined on execute statement or on DD statement. In fact, you can use proc overriding technique to change the file name or override the file name which is defined in your catalog procedure. And the best part is you are not required to change anything in your catalog or Instream procedures. Now let's talk about another important topic, that is JCL symbolic parameters. And they're very important from programmer perspective because they with the help of JCL symbolic parameters, you can write catalog and in-stream procedures in a more generalized way, right? And with the help of set statement, you can set the value of these parameters, and those procs or those catalog and in-stream procs can be used across multiple jobs. And you only need to just change those parameters with the help of set statement. So let's begin with the definition of symbolic parameters. In layman term, symbolic parameters are used to write catalog or in-stream procedures for general use. When you use symbolic parameter, you don't code the actual parameter value in the procedure. Instead, you code symbolic parameter that can take a specific value when you invoke the procedure from the JCL. To code a symbolic parameter in a procedure, you use a name that starts with an ampersand. The name can be any meaningful name you want as long as it's not a keyword parameter on execute statement. For example, ampersand time or ampersand region would not be a valid name because both are keyword parameter on an execute statement. But ampersand class and ampersand space are acceptable names. So following are the important rules that you should always remember when you are defining symbolic parameters in procedure. So first and foremost rule is that you must code a period as a delimiter between the symbolic parameter name and the text that follows it. If you want to code a period to appear immediately after a symbolic parameter, then you have to code two period instead of a single period. Second important rule is that if you want to nullify the value of symbolic parameter, then you can code the symbolic parameter followed by an equal sign, and after that you are not required to specify any value. The following example illustrate how to use symbolic parameters in your catalog or Instream procedure. So in this example, we have a catalog procedure which is stored in system library, that is sys1.proclib, and the catalog procedure name is emptx010. So the proc is actually using two datasets. First one is employee master with a DD name as empmast, and the second one is employee report, which is actually with a DD name emprept. If you look at the dataset name, you will notice that instead of using a high-level qualifier, I've used symbolic parameter. So in this case, the symbolic parameter is %prq dot, and I pass the value of this symbolic parameter when I'm calling the catalog procedure. So if you look at the JCL, sample JCL, which is given underneath, so there's a step 01, which is actually an execute statement, which is invoking the catalog procedure, that is emptx010. And after the name of the catalog procedure, you have comma followed by the value that I want to pass to these two particular symbolic parameter. So I've passed the value of class as f, and the value of PRQ symbolic parameter is TP01. So I hope you remember, if you look at the previous slides, there I've used the hard-coded value as TP01, but in this case I'm passing the same value with the help of a symbolic parameter. So you might be thinking that why I'm not using ampersand when I'm passing the value to these symbolic parameters. So the answer to that question is that whenever you define or use symbolic parameters in your procedures, so at that time you're required to specify ampersand. And in case if you want to pass value to these symbolic parameters from your JCL, then you are not required to use ampersand. So you have to follow the same practice the way I've just showcased in this particular example. The beauty of symbolic parameter is that you can write your procedure in a more generic or generalized way, and it will help you in using those procedures in multiple jobs by only changing the value of symbolic parameters. For example, let's say you have a proc and a job which is running in production, and you want to test that job in your test environment. So what you can do is you can simply get a copy of that particular job in your test environment, change the symbolic parameter as per your test environment, and simply you can run that job. And due to this flexibility of symbolic parameters, it is always recommended that you should use symbolic parameters while writing your procedures. Now let's talk about the set statement, which is generally used to assign value to these symbolic parameters. And thereafter, we will talk about how you can concatenate these symbolic parameters to create different job control statements in your procedures. The set statement is another important way to assign values to the symbolic parameter. In contrast to a proc statement that assigns default value or a procedure invoking execute statement that provides runtime value, the set statement lets you set the value of symbolic parameter at any point or time within your JCL. But remember, the set statement value can be overridden by any value that are assigned in a subsequent proc or execute statement in that job. Now let's talk about the syntax of set statement. So the syntax is pretty simple and straightforward. You have DD name, after that you have set keyword followed by symbolic parameter. After that you have to specify the value that you want to assign to that particular symbolic parameter. And similarly, if you have multiple symbolic parameters, then you can use comma to provide other symbolic parameter value. So if you look at the example, So again, we are using the same example. So we have a catalog proc which is stored in a system library that is sys1.proclib, and we are using a symbolic parameter that is %prq and %class. And if you look at the JCL, and this time what I've done is I've used the set statement to assign class value as f and prq equals to tp01. And if you notice the step 01, which is actually an execute statement to invoke the catalog procedure, that is emptx010. So on this step also, I've specified the symbolic parameter class equals to g. Now in this situation, the value of class parameter which was specified on execute statement will going to override the value which was specified with the help of set statement. So this is an important point and you should always remember that. Now let's focus on how to concatenate symbolic parameters with constant value or with any other symbolic parameters, and how you can use this symbolic parameter concatenation to generate various DD statements or execute statement in your catalog or Instream procedures. Now, as you know that symbolic parameters can be concatenated with any other symbolic parameter or with any constant or with any text. So in that situation, if you want text to appear immediately after a symbolic parameter, then you must code a period as a delimiter between a symbolic parameter name and the text that follows it. And if you want a period to appear immediately after a symbolic parameter, then you have to code two parameters in a row. So the first one acts as a delimiter marking the end of a symbolic parameter, and the second one will act as a part of a JCL statement. For example, when you're writing a DD statement, so in that case you need period, right? And in case if you want to nullify the value of symbolic parameter, so as always, you can code the symbolic parameter name followed by an equal sign with no value. Now let's go through the following example table to understand how you can concatenate symbolic parameters to accomplish your requirement. So this table includes four different columns. First one is serial number, second one is concatenated symbolic parameters, third column is a value column that will outline the value which will be assigned to these symbolic parameters. And in last column, you'll see the result, what would be the outcome after you assign the value to the symbolic parameters. So in first example, you have a DSN name followed by an equal sign, and after that you have a symbolic parameter that is %var1. And the value that I've assigned to this is TP01. So the output is TP01. So the DSN followed by equal sign will going to have TP01 once it is being translated. When you run your JCL, so you'll have TP01. In second example, you have DSN name followed by two symbolic parameter that is var1 and var2. var2 is actually specified in simple brackets, and I've assigned a value as TP01 and EMP_sal. So the output is DSN name equals to TP01 and in bracket it is EMP_sal. So in case if you want to specify a member name, so this is how you can concatenate two different symbolic parameters along with special characters to specify the PDS and its member name. Similarly, in example 3, we'll try to construct the dataset name with the help of symbolic parameter. So again, you have a DSN name followed by an equal sign, and after that you have %var1, which is a symbolic parameter. Then you have period dot a dot file. So I've passed the symbolic parameter value as TP02. So my output would be DSN name equals to TP02.a.file. So this is how you can construct the dataset name with the help of symbolic parameters. Similarly, in fourth example, I want to concatenate symbolic parameter with a text. So in this case, %prc name dot lib. So you notice that there is a single dot because I want that after symbolic parameter value, there should be a text, right? So in this case, I've specified proc as an input value to the symbolic parameter and the output is proclib. So this is how you can create the member name or dataset name or any other job control statement as per your requirement. Now the next topic is very important from the programmer's perspective, and at the same time it's a bit confusing. So let's try to understand how you can use JCL condition parameter and JCL if then else statement to process mainframe job conditionally. The following example is a graphical representation of a job. This job includes 9 different steps, and each step is performing a specific task to produce a monthly tax report. So if you notice the flow diagram, the job steps are dependent on one another. And in case if any of the job step ends abnormally, then the remaining job steps will not be executed. But conditional processing allows you to execute program conditionally. In other words, you can specify whether to execute a job step based on the result of previous job step. So in the following example, I can very well execute step 09 based on the return code of any of the previous step. So let's say if my job fails on step 04, even then also I can execute step 09 based on the return code of step 04. Now let me quickly summarize the important points that we have discussed so far, and after that I'm going to explain the syntax of JCL conditional parameter and if then else statement. So the first point is that conditional processing of JCL is a technique by which you can either execute or skip the job step based on the previous step return code. Second important point is that you can use either JCL COND parameter or if then else statement to process job conditionally. Third point is that you can use JCL conditional parameter on both execute statement and job statement. And the last point is there are two important terms that you should always remember. First one is step return code and second one is job completion code. A step return code is issued for every job step that is executed in a job. If the step ends normally, then the return code would be 0, and in case if it fails due to some problem, then the value would be between 1 to 4095. Similarly, a job completion code is generated when a job is completed. If the job ends normally, the completion code is 0, and in case if job fails due to some reason, then the completion code consists of 3-digit code with a prefix of S. In this case, it can also be called as append code. Now let's talk about the syntax of conditional parameter. So the syntax of conditional parameter is fairly simple and easy to understand. You have conditional keyword followed by an equal sign, and thereafter you have two subparameters. First one is value and second one is operator. So the possible value of operator field is greater than equal to, less than equal to, and not equal to. Apart from that, the value subparameter is used to specify a numeric value of a return code. So it could be 4, 8, 12, 16 depending on your requirement. Now as you know that conditional parameter can be used on job statement and execute statement. So first we will focus on how you can use conditional parameter on job statement. So when you specify the condition parameter in a job statement as shown in the following table, you specify the condition that caused the job to stop processing. For example, suppose you have a job with several steps and if any of the step issue a return code of 4 or more, the job should stop processing and bypass the remaining steps. In such a case, the condition parameter would be coded as condition equals to 4 comma less than equals to. This means that if 4 is less than or equal to the return code issued by any job step, the remaining job steps are to be bypassed. So if the return code is 8, the remaining steps are bypassed because the condition is true. In contrast, if the return code is 0, the condition is not true, so the job continue with the next job step. Now the table on the left showcases the relational operator that you use to code conditional parameters. And the table on the right illustrates how different type of conditions are handled. The table on the bottom right is used to specify how you can use conditional parameter in your job statement. Now let me quickly explain the examples that I've specified in second table. So there are three examples. So first one is condition code equals to 4 comma GT, that is greater than. So in this case, Your job will continue in case if the step return code is greater than equal to 4, and your job will terminate in case the step return code is less than 4. Similarly, you have condition code equals to 8 comma greater than equal to. So in this case, your job will continue in case if return code is greater than 4, and it will terminate in case if return code is less than equal to 8. Similarly, you have third, that is condition code equals to 0 comma not equals to. So the job will continue if the step return code is 0, and in case if step return code is not equals to 0, then the job will terminate. Now, as you know that conditional parameter can be used at job level or at an individual step level, right? So the conditional parameter on execute statement is more flexible than conditional parameter on job statement. And the syntax of conditional parameter used on job statement or on execute statement is almost same. But with the help of additional subparameter, you have more control over the execution of individual job step. You can specify a return code and a relational operator to determine whether to skip a particular job step instead of all the subsequent job steps. You can also specify a step name in order to test the return code for a specific job step. And you can also use two additional subparameters, that is even and only, in case if you want to execute certain job steps if your job fails. Now let's try to understand the use of conditional parameter with the help of an example. So the first table outlines the difference between even and only subparameter. So in case if you have specified even on any job step, then the system will execute the job step even if a previous job step has abandoned. Similarly, if you have used only subparameter, then it will tell the system to execute the job step only if a previous job step has abandoned. So in nutshell, the only subparameter is useful for steps that perform recovery processing in case if your job abandoned, and it is usually coded as the last step in your JCL or a job. The even subparameter is useful for steps that do not depend on the successful execution of previous steps. So if you do not specify even or only subparameter in any of the step in a job, then in case if any of the step fails, then rest of the subsequent steps will be bypassed. Now let's focus on second table that outline two examples. So in the first example, the step will be bypassed if the previous step return code is 8 or greater than 8. Now in second example, the current step will be bypassed if step 2 return code is 8. So in the similar fashion, you can use to check the return code of previous step or any specific step. You can also specify multiple conditions with the help of logical operators. Now let's focus on third table. It actually outlines the sample JCL which is using conditional parameter on step 1 and step 2. So if you look at step 1, I'm using conditional parameter as 07, comma, less than. And in step 2, I have specified the conditional parameter as conditional equal to 8, comma, equal to, comma, step 01. So in this case, I'm checking the return code of step 01. So during the initial days, the conditional parameters were the only option for the conditional processing of the JCL. But because it is awkward and confusing for the programmers, the later version of the operating system added 3 JCL statements that works together for the purpose of conditional processing. And these statements are if then, else, and ENDIF. Now let's try to understand how you can use if then else statement to process job steps conditionally. So here's the syntax of if then else statement. And to begin the conditional execution, you have to code if statement followed by the condition that you want to test. After the condition, you have to code then clause followed by whatever JCL statement you want to execute if the condition is true. And if required, you can code else statement followed by whatever JCL statements you want to execute in case condition is false. And finally, you end the conditional structure with ENDIF. So with the help of an if then else statement, you can specify conditions in your JCL. And it works in the same way as if you are coding if-then-else statement in your COBOL, Java, C++, or any other high-level programming language program. And in order to specify the relational expression or condition in your if-then-else statement, you can use the keyword RC followed by an operator and then a specific value that you want to check. And RC is generally used to specify the return code of a previous job step. And if you want to specify the return code issued by a specific job step or a procedure step, then you can use stepname.rc or procstep.rc. Now let's look at a couple of examples so that you can understand how exactly you can use if then else statement to process job steps conditionally. So again, you have a table on the right hand side. So this is basically an operator that you can use to specify your relational expression along with RC as your return code of the previous step. Now in the following example, which is outlined in table 2, I have used if then else statement to process job steps conditionally. So in this example, step 03 is executed if any of the previous job step has an issue or a return code greater than or equal to 8. Otherwise, step 4 will be executed. And there's an important point that I want to highlight, that if you notice that I have not specified the name field for any of my condition like if, else or ENDIF, right? So if you are not using any name field for any of these conditional statements, then you should leave column 3 as blank and you should start your if, else or ENDIF statement after that particular position itself. So this is how you can use conditional parameter or if then else statement to process your job conditionally or as per your requirement. Now let's focus on our next section, that is how to use restart parameters to restart your job. And in this section, we will try to understand what are the different ways of restarting your job in case if it fails. So when a program abandons or the system fails, you may need to restart a job from a specific point or a step where it had failed instead of restarting it from the top. Now the question is it possible to restart a job from a designated step instead of restarting it from top? Well, the answer is yes. It is possible to restart a job at a point other than at the beginning. To be very precise, you can restart a job from a designated step or you can restart a job from a checkpoint within a program. So there are two different parameters that are used to restart a job. First one is the restart parameter that can be coded on the job statement and it is used to handle your job failure. So you need to just specify the restart parameter following by an equal sign and then the step from where you want to restart your job. In addition to these two parameters, you have JAS2 and JAS3 and both provide statements that can be used to restart job automatically in case if there is a system failure. So in this session, we will only focus on JCL restart parameter because that is very commonly used to restart your job. So now let's focus on the syntax of restart parameter. The syntax of restart parameter is pretty simple and easy to understand. You have to use the restart keyword followed by an equal sign, and after that you have to specify subparameters as per your requirement. So the first possible value is asterisk and it is used to specify that the system is to restart the job from the first job step. Second one is step name, and in case if you want to restart your job from a specific step, then you have to specify the step name. And third one is to specify the step which is included in a proc. So for example, you're using a catalog procedure and your job fail in any of the step which is included in catalog procedure. So you can use step name dot proc step name to specify the step within the proc from where the JCL should be restarted. And finally, the last one is check ID. It is generally used to specify the name of the checkpoint at which the system should restart the execution. Now in the following example, I've used the restart parameter to restart the job from a specific step, whether in a job or in a proc. So in the first example, I've used the restart parameter, that is restart keyword followed by an equal sign, and after that I've specified the step name. So that is step 02. So actually I just want to restart my job from step 2. So you need to just specify that and you need to just resubmit your job and the job will be restarted from step 2. In second example, the JCL is using a catalog procedure, and in this case the step from where I want to restart my job is in catalog procedure. So what I've done is I've used the restart keyword followed by an equal sign. After that the step name, that is step 03 dot emp text, which is actually proc step name. And after including all these details, you simply need to resubmit your job so that you can restart your job from a specific point. Now, before discussing the next topic, I would like to mention that you should be very careful when you're writing restart parameters in your JCL. So you should always keep in your mind that it is not possible to restart job from a specific step where it had failed. And there are multiple reasons behind that. Maybe your job step is actually using a temporary dataset, or maybe it is using a dataset which was created by some other step and it cannot be used now, or probably it could be a checkpointing issue. So as a good practice, you should always scan through your JCL and try to understand what is the safest place where you can restart your job. Ladies and gentlemen, now let's talk about generation data group or GDG. So in layman term, a generation data group or GDG is a collection of two or more chronologically related versions of the same dataset. Generation data group are non-VSAM sequential dataset that resides on tape or dash D. Generation data group are generally used to maintain the backup of critical data, for example, monitored transaction. And if something goes wrong, you can easily restore the data from the backups and redo the processing. The naming convention of generation data group is slightly different from the dataset name. The operating system add absolute number at the end of the dataset name so that you can uniquely identify each dataset within the generation data group. So the format is dataset name dot absolute number followed by version number. Absolute number is prefix with letter G and version number is prefix with letter V. So the absolute number value lies between 0000 to 4 times 9 and the version value lies between 00 to 99. So here's an example of generation data group dataset name. So if you notice that you have a dataset name, after that you have an absolute number followed by a version number. So ladies and gentlemen, I've created a detailed video of what is GDG and how you can correlate this GDG analogy with Windows system. And what are the different operations that you can perform on GDG, how you can define a GDG, how you can alter a GDG, how you can delete a GDG, and how you can use GDGs for taking backups. So I would request you to just go back to our channel, watch those videos to have an in-depth understanding of generation data group. Now our next topic is JCL utilities. And in this video, we will talk about two important utilities. First one is IEBGENER Utility, and then we will talk about JCL SORT Utility. However, there are so many different utilities that is used on mainframe, and I've created separate videos on all those utilities. Please do visit our channel in case if you want to learn more about these utilities. So before I start with IEBGENER Utility, let's try to answer or let's try to understand what is JCL utility or what do you understand by the term utility. So in layman term, mainframe utility programs or just utilities are the programs that can be used for common data processing functions like copying or printing a dataset. These utilities are supplied with IBM ZOS and they are widely used in batch jobs. Now let's talk about IEBGENER Utility. The IEBGENER Utility is a copy program that has been a part of operating system since the first release of OS 360. One of its many uses is to copy a sequential dataset, a member of partition dataset or PDSC, or probably ZOS Unix System Services files such as HFS files. As a result, this utility can be used to backup or restore sequential datasets. You can also use this utility to print a non-VSAM sequential dataset by copying it to a sysout dataset. Finally, the common use of IBGENER utility is to create, reformat, and backup non-vsam sequential datasets. Now let's try to understand what are the different DD statements that are required by an IBGENER utility. So there are four different DD statements that are required by an IBGENER utility. So the first one is sysut1, and it is used to specify the input file. The second DD statement is sysut2, and it is used to specify the output file. The third one is sysprint. It is an output message file, and the last one is sysin, and it is used to specify the control parameters. And if you do not want to use control statement, the sysin DD statement is still required. So you must code it as dummy dataset. Now let's try to understand what are the different steps you need in a JCL and how you can invoke IBGENER utility with the help of a batch job. So in order to execute an IBGENER utility from a batch job, you need three kinds of control statement. First one is a job card, which would provide all the information related to your shop. Then you need an execute statement to invoke the IBGENER utility. After that, you need couple of DD statements and sysin card that is required in case if you are just doing reformat, and in case if you are not doing any kind of reformat, then you need to specify sysin as dummy. So here's a sample JCL that outline how an IBGENER utility is used to take backup. So the first two steps is a job card. After that you have comment section. Then step 01 is actually executing your IBGENER utility. Then you have sysut1 and sysut2 DD statement, which is used to specify the input and output file. After that you have sysprint followed by sysin, and in this case I do not specify any control parameters, so I've used sysin DD as dummy. Now before I show the live demonstration of how you can use IBGENER utility to perform various operations, let me ask an interview question. So the question is, what is the basic difference between IBGENER utility and IEB copy utility? If you know the answer, then write down in the comment section. Otherwise, I'll give you the correct answer in the last section of this presentation. So here's my sample JCL, and it includes 4 different steps, and each step is doing a specific task. Now let me quickly explain the JCL. So the first two lines is a job card which will provide all the information related to your shop. After that, I've included basic description about the job, and it is always a good practice that you should write some lines about the job or the step which is being used in your JCL so that anybody can understand what exactly this job is doing. Then the first step of this JCL is to take the backup of dataset with the help of IBGENER utility. And if you notice, step 01 is invoking IBGENER utility, and the input dataset is provided with the help of sysut1 DD statement. And the backup dataset name is provided with the help of sysut2 DD statement. The sysin DD statement is coded as dummy because I'm not using any control parameters while copying data from the input file to the output file. In step 2, I've used IBGENER utility to print the dataset in spool. So in order to print the dataset in spool, what I've done is I've just provided sysut2 DD statement with sysout equals to star. However, there is no change in other DD statements of this particular step. Step 3 of this JCL showcase how you can use IBGENER utility to copy a member of PDS from one PDS to other PDS. And finally, step 4 of this JCL showcase how you can use IBGENER utility to reformat data while copying it from source file to the destination file. So in this case again I've used sysut1 to provide the input file and sysut2 to provide the output file. And in this case, I've used sysin DD statement to provide additional control parameters so that it can reformat data while copying from source to destination file. Now let me quickly explain the control card. As you know that you can use IBGENER utility to arrange or convert data format as you copy the dataset. So in this case, the generate statement summarizes the specification that you provide in the record statement, and the record statement provide the specification of the fields of the output record. Now the generate statement uses two subparameters. First one is max field and the second one is max limit. So max field is used to specify the number of field parameters in a record statement, and max limit is used to specify the number of bytes of literal dataset included in the field parameter in record statement. Now before explaining the record fields, let me explain the input file. So if you look at the right hand side of your screen, this is the input file that I'll be using for step 4. So the file has 4 different columns. First one is employee ID. After that you have employee name. After that you have department code, and the last column is employee salary. Now requirement is to prefix the salary of an employee with a static information, that is EMP space sal hyphen. And to accomplish this requirement, I've added record field statement in sysn. Now let me quickly explain the record field parameter of sysn. The record field parameter accepts 4 different subparameters. First one is length, which is the length of the field in the input record. Second one is location or literal. The location would be the starting position of the field in the input record. And in case if you want to hard code something specific or some static string, then you can use literal over there. The next one is conversion, and it is the conversion operation to be performed on the field. And the last one is out location. So this is the starting position of the field in the output record. So the value of first subparameter is 23, 1, space, 1. So it says like I would be copying first 23 byte from the input file, and the starting position of the input file is 1 and the starting position of output file is 1, and I'm not using any kind of conversion, so my conversion is specified as spaces. The next set of subparameter is to include static string as per our requirement. So the subparameters are 8, which is the total length of the static string, that is EMP space sal hyphen. After that you have conversion, so we are not doing any conversion, so I've specified as spaces, and after that I've specified the starting position of the output file, and that is 24. Similarly, the last set of parameter is to copy the salary column from an input file to the output file. Now let me quickly submit the job and show you the output. Now the job is submitted and we have got the job number. Let me just click on that and it's retrieving the information. So our job is completed with maxCC 0. Now let me showcase the output of this particular job. So let me close this particular window, and on the first column you have your JCL, and in next column I have my input and output file. Third column also showcase the output of the JCL, that is sysout, and the member which is being copied in step 3. Now if you notice column 3, it is actually showing the dataset which was printed in spool by step 02. Now again, column 3 showcases the PDS member which was copied to a backup PDS in step 03. Now let me showcase the output file which is generated by step 04, and in this file we have prefixed the salary of an employee with a static string, that is EMP space sal hyphen followed by employee salary. So this is how you can use IEBGENER Utility in JCL to create, reformat or take backups of non-VSAM sequential datasets. Now coming back to our original question, that is, what is the basic difference between IEBGENER and IEB copy? Well, the correct answer is that both utilities are used for data processing. IEBGENER utility is used for non-VSAM sequential dataset. It is used to copy, create, print, or reformat dataset as you copy. On the other hand, you have IEB copy, which is primarily used to perform operation on personal dataset or PDSE. It is used to copy, merge, compress, or archive a PDS into a sequential file. Now let's talk about our next utility, that is JCL SORT Utility. As you know that sequential files are generally used to store data in mainframe. This data could be anything. It could be your monetary transaction, it could be your sales transaction, or it could be any data that is related to your application. Then before the record in these files can be processed, they often need to be sorted or merged into an appropriate sequence. And to perform the sorting or merging of data, you use JCL SORT Utility. In layman term, JCL SORT Utility is an application program that can be used to perform different operations such as sorting, merging, copying, or joining data from two or more files as per your requirement. Now let's go through a simple flow diagram to understand the working principle of JCL SORT Utility. As you know that JCL SORT Utility can be invoked with the help of a JCL. And whenever you invoke a JCL sort utility, you need to provide an input file on which the different operations need to be performed. For example, if you want to extract certain record based on a criteria, or probably you want to merge two different files, right? So input file is the one on which the operation will be performed. After that, you have sort work file. So JCL sort utility actually use this file for the internal processing, right? And what would be the outcome of the entire operation will be written into your output file. And the selection criteria is specified with the help of sys and card. Now let's go through a sample JCL to understand what are the different DD statements you need to specify in case if you want to invoke a sort utility with the help of a JCL. So here's a sample JCL, and this JCL is invoking sort utility to sort employee annual text file. For the explanation perspective, I've divided the entire job into three different sections. First one is job card, and if you look at the first two lines, it is used to specify the job card, which includes detail related to your project or to your shop. After that, you have next three line, which is a comment, and this is a good practice to include the generic or brief description of what this JCL is actually doing. The next section is actually a combination of execute statement and DD statements. So execute statement is used to invoke your sort utility, and after that you have couple of DD statements which is used to specify your input file, output file, and the sort work file. So if you look at the DD name, that is sort in, it is actually used to specify the input file. The DD name sort out is actually used to specify your output file, and sort work 01 is actually used to specify your work file. The next DD statement is sysout, and it is generally used to print or store messages which is generated by sort utility. And the third section is sysincard, and it is generally used to provide the inclusion or exclusion criteria. Now let me quickly explain the sort card which is used in this JCL. So you have sort fields, which is actually a keyword. After that you have an equal sign, and thereafter in simple bracket I've specified the field on which I want to apply the sort criteria. So 9, 5. So 9 is actually a starting position of a field in an input file, and 5 is actually a length of that particular field. After that, I've specified the format of the field, that is CH, that is character, and then I've specified the sequence or sorting sequence. So I've used ascending. Now let me showcase a different way of writing the same sort card. So in this case, what I've done is I've used the sort field followed by an equal sign, and after that I've specified the position, the length of the field, and the sequence, the order in which I want to sort the file. And after that, instead of providing the format before the sequence, I've included format separately. So I've used the format keyword, and after that I've specified ch. And similarly, you can use logical operators to include more than one field in your selection criteria or in your exclusion criteria. Now let's try to understand the syntax of sort in detail. So here's the syntax of sort statement. So you have sort field, which is actually a keyword. After that you have an equal sign, and thereafter you have couple of subparameter. So first subparameter is position, then you have length, after that you have format, and the last one is sequence. The position subparameter specify the starting position of the control field in the specific input record. Length is used to specify the total length of a control field in the input record. Format is used to specify the format of the control field in the input record. And the last one is sequence. It is used to specify the sorting order of the data, whether it is ascending or descending. Now let's talk about additional subparameter. First one is equal and no equal. So equal means that the order of the record in the input file should be preserved in the output file. And no equal means that the input order will not be preserved. The next parameter is file size, and it is used to specify either the exact number of records to be sorted or merged or an estimate number of records to be sorted. The next parameter is skiprec, and it is used to specify the number of records you want to skip before starting to copy or to sort the input dataset. And the last one is stop after, and this parameter is used to specify the maximum number of records you want to accept for sorting or copying. Now let's talk about the last topic of this particular video, that is what is the difference between JCL-lib and include statement. So as you know that sys1.proclib is normally used to store system-oriented catalog procedures, the procedures which is supplied by IBM. Now let's say you have created a catalog procedure and you have stored that in your personal PDS. So in order to invoke that catalog procedure from your personal PDS, you need JCL-lib statement in your JCL. Otherwise your JCL will going to fail, because by default it will search your catalog procedure in the system library, that is sys1.proclib, and you have stored that in your personal PDS, so JCL will fail, right? So in nutshell, JCL lib statement let you identify the libraries as a private procedure library that system should search to find a specific catalog procedure that you are trying to invoke from the JCL. And just in case if you have more than two PDS and you want to specify the search sequence, then you can also do that with the help of an order keyword. So you can use JCL lib followed by a space and then order, and after that you can specify the PDS in a sequence in which you want system to search. And always remember that JCL statement must appear after the job statement but before an execute statement in that particular job. Now the next important statement is include statement, and you can use include statement to copy text directly into your job stream. The include statement works like a catalog procedure, and the only difference is that you do not code almost all job steps in the include statement. In general, you just put the common steps, for example, DD statements. You can just code the DD statements in include statement and store it as a PDS member. And whenever you want, you can just directly include that in your JCL. So it's pretty handy. Like it just increases the code reusability. Like you're not required to code same set of statement again and again. Now here's a sample JCL that showcase how you can use JCL lib order and include statement in your JCL. So if you notice, I've included JCL lib order before an execute statement and after a job statement, right? And I've specified two PDS, so system will going to search the first PDS, that is tp.tst.proclib, and in case if my catalog procedure is not present in that library, then only it will go into second one, that is tp.prod.proclib. And similarly, if you look at the step 2, where I just want to include DD statements, which is stored as a part of PDS member, and in this case, I've used include statement to include all the DD statement which is required for step 2. So ladies and gentlemen, this marks an end to our today's session, and in case if you have any question or any suggestion, then please do mention that in the comment section, because your suggestion and your feedback is very important for us,